Good afternoon, guys. How are you? I hope you're doing well. Here we have the final revision worksheet we will solve today in this session. They're gonna help you to prepare for your final exam. So this is the final revision for calculus. We will start first by integration by parts. We will use this formula. The integral of u dv is equal to uv minus the integral of v du, and it based on the word LIPET, L-I-P-E-T, and we know that L stands for logs or len, I stands for inverse trig functions, and P stands for the polynomials, and E stands for exponential, and T for trigonometric functions. Here we have some solved examples. I'm gonna send this worksheet for you, and let's pick here one question to practice and revise this topic, integration by parts. Yes, let's take example 2. Yeah, example 2, the integral of x cosine x dx, and u is given as x, and the dv is cosine x. So we can write here the integral of u dv equal uv minus the integral of v du, and we can let here that u will be the x, the polynomial, and the cosine x dx will be the dv. So we can let here the u, we can use the Tipler way here, so we can make two columns. The first column d over dx, and the second column for the integral. So in the first column we will let here x, and we will skip find the derivative until we get 0, so it's 1 and then 0. In the other column we will write cosine x and find its integral. The integral of cosine is sine x, and the integral again is negative cosine x. Then use the arrow, draw arrow here like this, and use the signs positive and the negative. Next we have to write the final answer, x sine x, and then negative negative, which is positive cosine x, plus the constant of integration, which is c. Yes, this is our final answer. Let's take, guys, one more question. Yes, this question, let's copy it and paste it in another page. Here the integral of e to the power of x cosine x dx. Yes, we know this famous question. We have to solve here integration by parts twice. So first of all, according to the word LIPET, the u will be e to the power of x, and the dv is equal to cosine x dx. We will find the derivative of the first, we will find the du and the integral of the dv, as you know. So we have du equal e to the power of x dx, and the dv, its integral v equal the integral of cosine is sine x. uv minus the integral of v du, and don't forget also to write the head of the question, which is the integral of u dv. The u here, which is e to the power of x, and the v, which is sine x, minus the integral of v, which is sine x, and the du, which is e to the power of x dx. Yes, we should do the by parts again, since the integral of sine x ex is consisted of the product of two functions. So yes, u equal e to the power of x, and dv equals the sine x dx. Yes, so we have the du equal e to the power of x, the same, and the dx, and the v is the integral of sine, which is cosine, negative cosine x dx, negative cosine x. And apply the integration by parts for the second time, and don't forget, guys, to write the head of the question, which is e to the power of x cosine x dx is equal to e to the power of x sine x minus uv minus the integral of v du for this part only, which is e to the power of x cosine x, so it's gonna be positive, and then minus negative, 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 so it's still negative the integral of cosine x e to the power of x cosine dx. And then we can move it to the other side there, to the integral of e to the power of x cosine x dx is equal to e to the power of x sine x plus e to the power of x cosine x, and then divide both sides by 2 to eliminate the 2, and to write the integral of e to the power of x cosine x dx as it is in the left hand side, and divide the right hand side by 2 plus c. Yeah, this is our final answer, and then highlight it. Let's move on, guys, to another topic here, which is derivatives and integrals of exponential and logarithmic functions. Yes. Yeah, here we have this table. It's very, very important. You have to know it well. What's the derivative of e to the power of x? What's the derivative of a times e to the power of x, and so on. So let's maximize it, right? E to the power of x, its derivative is e to the power of x, and a e to the power of x, its derivative is a times e to the power of x, such that a is a constant. E to the power of kx equal k e to the power of kx, and a e to the power of kx equal a times k e to the power of x, and we will see this in the next examples. Okay, and you know, guys, the ln x, its derivative is 1 over x, and a ln x is 1 over x. If we would like to find the integral of 1 over x, it will be ln x. Yes. Integral of a to the power of x, for example, is a ln x, and the integral of 1 over x is ln kx, and so on. Let's take some examples, guys, of this lesson. Evaluate each indefinite integral. The integral of x to the power of negative 1 dx. We know all that x to the power of negative 1 can be written as 1 over x dx, and it's simply, yeah, ln x plus what? Plus c. Number 2, according to the table. Number 2, the integral of 3x e to the power of negative 1. 3 is constant. 3 is constant, so it will be 3 ln x plus c. Number 3, integral of negative ln 1 over x, so it's a negative ln x. Number 4, it's ln x direct, and the integral of negative e to the power of negative x is the same, negative e to the power of x plus c. Integral of e to the power of x in question 6 will be e to the power of x plus c, and the integral of any exponential function e 2 times 3 to the power of x dx, we will let the 2 as a constant, and then we will find the integral of 3 to the power of x. Yes, so we can write it as 2 integral of 3 to the power of x dx, and 2 constant, leave it the same, and the integral of 3 to the power of x is 3 to the power of x over ln 3 plus c. Question 8, same. The integral of 3 times 5 to the power of x, it's 5 to the power of x dx, which is equal to 3, and 5 to the power of x, and this all over ln 5 plus c. Okay, that's all for this lesson. Let's move on to our next lesson, which is 7.3, integrating trigonometric functions. Yeah, you know this lesson, it's very, very important with the products of sine and cosine. Let's take the first example, how to find the integral of sine to the power of 5x cosine to the power of 8x dx. We have to, yeah, let's copy it here. Yeah, we will split off here sine to the power of 5x as the product of 2 factors, so we can write it as sine to the power of 2 all to the power of 2 sine squared x all squared, and then multiply by cosine to the power of 8x, leave it now, and then we still have sine x dx. So sine to the power of 5x, we split it off into the product of two factors, sine squared all squared times sine x, and we leave we can write it as sine squared x. We can write it as using the relevant identity 1 minus cosine squared x, and this all squared cosine 8x and sine x dx. Yes, we will use u substitution. We will use u substitution. We will let u equals cosine x. Yes. Du equal the derivative of cosine, which is negative sine x dx. Okay. We will move back to our question and substitute. We replace every cosine by u. So we have 1 minus u squared and this all power 2 times u to the power of 8 times sine x, leave it now, and you will know why. And then we're gonna replace the dx in the previous formula as du over negative sine x. You will see that we can cancel right now sine x with sine x. No sine in the question right now. And then we can expand first 1 minus u squared all squared as, yes, we can expand here. Yeah, there is negative here for the 1 minus 2u squared plus u to the power of 4 and then times u to the power of 8 du. Yes, which is equal to negative. We can multiply here the negative in sign. Yes, we can use distributive property and multiplying a negative u to the power of 8 plus 2u to the power of 10 minus u to the power of 12 du, and then integrate each one separately by adding 1 to the exponent and divide by the new exponent. So plus u to the power of 11 over 11 minus u to the power of 13 over 13 plus c. Okay, and also guys, you have to replace u again by its original value. I think that we let u as cosine, so it's a negative cosine u to the power of 9 x over 9 and plus 2 over 11 cosine to the power of 11 x minus 1 over 13 cosine to the power of what, 13 x plus c. Okay. Yes. Let's take one more question. Let's take one more question here, integrating the trigonometric functions. Let's take question, yeah, I can give you a hint here in question 2. Cosine squared can be written as 1/2 plus 1/2 cosine 2x dx, and then you can integrate each part separately, will be half x plus, yes, minus, plus half sine 2x over what? Over 2. Now to integrate here, then 6 to the power of 6x 10 squared x dx. Yes, in this question we can also split off sec to the power of 6 x into two factors. Let's write it as 6 squared all squared, and 6 squared x بعدين all squared times 10 squared x. This gives us here 6 to the power of 4, 10 squared, and 6 squared, we still have 6 squared x dx. طيب, you know the relevant identity of 6 squared, which is 1 plus 10 squared x all squared multiplied by 10 squared x multiplied by 6 squared x, and then we will use u substitution. The u substitution here, we will let u as 10x, and we know what's the derivative of 10. Yeah, derivative of 10 to find du here is 6 squared. Yes, so the du equal 6 squared x dx, and then find dx by dividing each side by 6 squared, du over 6 squared x. Yes, I will shift this all and minimize it and put it here, and then let's continue in our question. The integral of 1 plus u squared all squared all to the power of 2, and the 10 squared also is u squared times 6 squared. Leave it, we will cancel it right now. while substituting for dx, which is du over sec squared x. We can cancel out 6 squared with 6 squared. And expand 1 plus 2 u squared plus u to the power of 4 times u squared times du. Yes, using a distributive property by multiplying u squared by all terms inside here. U squared plus 2u to the power of 4 plus u to the power of 6 du. Then integrate by adding 1. 1 over 3 u to the power of 3 plus 2 over 3 u to the power 2 over 5, yes, u to the power of 5 plus 1 over 7 u to the power of 7 plus c. Replace again u as 10, so 1 over 3 10 squared, 10 cubed x plus 2 over 5 10 to the power of 5x plus 1 over 7 10 to the power of 7x plus c. Yes, that's all for this lesson, and let's move on, guys, to another topic. Let's revise here another important topic. Yes, 7.5, integrating by partial fractions. Yes, also this worksheet involves of questions that are very important to you. I would send this worksheet, guys, for you to study well. And let's solve here or practice for one question. Let's take the first, copy and paste. Yes, yes, ready. So how to know that we have to use here a partial fraction decomposition, since my denominator consists of two factors, both of them are linear. Yes, so let me take here x minus 9 over x plus 5x minus 2. And this all equal constant a over x minus 5 plus constant b over x minus 2. And we know what is the next step by multiplying here the whole equation by x minus 5 x minus 2. And you know what does it mean? It means that you have to multiply x minus 5 by the first and second and third term, both sides, to get rid of the fractions. And next step is to find the value of a and b. X minus 9 equal a into x minus 2 plus b into x minus 5. And simply to find the value of a first, we will let x equals 5. Yes, plugging in 5 in the question above in the previous step. So 5 minus 9 negative 4 equals 3a. A equals negative 4 over 3. Box it and highlight. Next step is to find the b by letting x equals 2. Substituting 2 in the question here gives yes, in this equation 2 minus 9, which is negative 7, and substituting to find the b, so we're gonna eliminate a and we have another equation in only b. Negative 3b equals negative 7, and simply b is 7 over 3. Okay, we will move back, guys, to our original question. You know, I'm gonna duplicate it and take a copy of it, يعني, and solve it below here, drag it down. Yes, and we will integrate each part separately with respect to x dx. Substituting by new values we have now, which is a and b. We have a is negative 4 over 3 and b is 7 over 3. Okay, and then we know how to integrate this part because the numerator involves the derivative of the denominator, so it's a negative 4 over 3 ln absolute value of x minus 5 plus 7 over 3 ln absolute value of x minus 2 plus c. I hope you understood this question, guys. Yes, the other question I would like to revise, the one that involved the long division. Yes, number 11, I don't think so it's involved here a long division, so don't try to do it by using long division. I will bring for you another question that has a degree of the numerator that is bigger than the degree of the denominator. So this one, we can factorize the denominator as x and x plus 3 and x squared plus 3, and do it easily by using a constant a and another constant bx plus c over x squared plus 3. But let me bring for you another example which is very, very important. We solved it before. Here we have the degree of the numerator is 4 and the degree of the denominator is 2, so you will find that we have to use here the long division. Yes, let's solve this question, please. Evaluate the integral, and you see that the numerator involved here fraction and that has a polynomial that has a degree of 4 and the degree of the denominator is 2. So using long division to break down this fraction into simpler and simpler fractions, write x4 plus x3 minus 5x2 plus 26x minus 21, and inside here x squared plus 3x minus 4. Using x squared by multiplying gives x to the power of 4 plus 6x is plus 3x cubed, yes, minus 4x squared, and then change the signs quickly and eliminate the first term. Negative 2x cubed minus x squared, and drop down positive 26x. Yes, so we can get now negative 2x multiply gives a negative 2x cubed and the negative 6x squared and positive 8x. Change the signs and then subtract, cancel out, so we have positive 5x to the power of 2 and plus 18x squared, plus 18 only x, sorry. Okay, and drop down negative 21 minus 21 plus 5 up there, so we have 5x squared. Yes, 5 times x squared is 5x squared. Okay, and then plus 15x, and then minus 20. Cancel the first term and subtract 18 minus 15 gives a 3x, and negative 21 plus 20, which is negative 1. So my remainder here is 3x minus 1. How to write your answer, but let me first to minimize this step. The step of long division equal the integral of the quotient which is x squared minus 2x plus 5 dx. We will integrate it separately, and plus the integral of the other part which is the remainder 3x minus 1, and this all over the divisor which is x squared plus 3x minus 4 dx. And the other part here we have to use partial fraction decomposition. We have to break down into this fraction into two parts. So we can use 3x minus 1 over x squared plus 3x minus 4. On the first part easy, we can do it, but the second part we can take it and solve it by using partial fraction decomposition. So we have to factorize first the denominator. So write 3x minus 1 over, open two parentheses, and factorize the denominator as x and x, and the 4 is 4 and 1. Yes, plus minus. This all equal a constant a over x minus 1 plus a constant b over x plus 4. And you can find the rest of the question. I will leave this question, guys, to complete, and don't forget to integrate the first part because we still have here some lessons we have to revise. Let's move on to trigonometric substitutions, and you know this interesting lesson based on this table, so we have to study this table well, guys, and also you can use it in the final exam. Root a squared minus x squared, if you have this expression in the integrand, you have to use x equal a sine theta. And if you have root a squared plus x squared, you have to use x equal a tan theta. And if you have root x squared minus x squared, you have to use x equal a sec theta. Let's see this while solving a question by using a trigonometric substitution. Yeah, let's pick here the second question, number 2, and solve it. Integral of 1 over x squared root 25 minus x. So when you see 25 minus x squared, you have to search in the table in the first slide. You have to check this table here, which one is 25 or a squared minus x squared. The first one, yeah, so the good substitution here is x equal a sine theta. Yeah, and the relevant identity 1 minus sine squared equal cosine squared. So we will let here the x equal a sine theta, and the x equal 5 now sine theta, and the dx is equal to 5, and the derivative here is cosine theta d theta. x squared بالمرة بيكون a 25 sine squared theta, and let's substitute in the question itself. Equal the integral of, make a fraction, 1 over x squared is 25 sine squared theta, and the square root of 25 minus 25 sine squared theta. The dx is equal to cosine, the dx is cosine x cosine theta d theta, 5 cosine theta d theta. We can simplify more, 1 and here 5, and you can let it outside as a constant. So it's 1 over 25, 1 over 5, sorry, and here we have cosine theta d theta, and down here we have sine squared theta. Inside the square root 25 we can take it as a common factor, تطلع outside the square root as 5, multiply by the 5 outside, which is what here, which is 25. So sine squared root 1 minus sine squared theta, okay, equal 1 over 25 the integral of, we know guys, cosine theta d theta in the numerator. In the denominator our story will finish right now, sine squared theta, and root 1 minus sine squared can be simplified as cosine squared using Pythagorean identity, and outside the square root is cosine. We can cancel cosine with cosine, and this leaves behind 1 over 25 the integral of 1 over sine squared theta d theta. We know that 1 over sine squared can be written as 1 over 25 the integral of cosecant squared. 1 over sine is cosecant, so 1 over sine squared is cosecant squared theta d theta. Yes, and its integral is simply is negative cotan, so my answer will be negative 1 over 25 cotan theta plus c. But don't leave your answer in terms of theta. Yes, you have to draw a triangle. No, not like this, like this one. Draw a triangle, put your theta. Yes, and remember what you let in the beginning, x equal 5 sine theta. So the sine is x over 5. The sine is what? X over 5. So it's opposite over hypotenuse. The opposite is x and the hypotenuse 5. So the other leg here, the other leg, which is the square root of 25 minus x squared. We know that cotan is the reciprocal of tan, and the tan is opposite over adjacent, so the cotan is adjacent over opposite. So it's a negative 1 over 25, the adjacent, which is root 25 minus x squared, and this all over what? X plus c. And that's all guys, and it's so easy right now. Okay, let's move on guys to another topic, 5.1, which is area between two curves. 5.1, area between two curves, very very important topic. We still have two topics here, this one and the other one, volumes of revolutions. For example, the question will be, for each problem find the area of the region enclosed by the curves. So let us start by the first question. The graph is already given, so it's easy now to identify which parabola opens up, which graph is upper and which graph is lower. Yes, so the upper one, yeah, I think it's the first, because 2x squared minus x plus 10 is a parabola opens up and it has a y-intercept which is positive 10, because if we extend the parabola here, it's gonna intersect with the y-axis at 10. So the upper one is 2x squared minus x plus 10, and the lower one now, because if we extend the parabola, will intersect at what? At 10. The lower parabola here is x squared over 2 minus 2x minus 1. Okay, x squared over 2 minus 2x minus 1. Okay, so it's clear now, guys, and we know what should we do here. So let me to cut this question and solve it in a separate, in another paper. Let me add one more page here. Yes, and cut this question. You solve it here in details. Yeah, if you have such a question, yes, you can write the area equal the integral from a to b of upper function minus lower dx with respect to dx. So the limits of integration here is 1 to 3. It's given here, it's bounded between 1 to 3 horizontally, and all your variables will be with respect to what? 2x. Let's write it from 1 to 3, the integral from 1 to 3. The upper function, it's 2x squared minus 8x plus 10, and the lower function minus x squared over 2. But wait, please, I will make a space here. Yes, make a line here like this. Yes, and write area equal. طيب. Minus what here? The lower function x squared over 2, and change the sign, plus 2x plus 1 dx. And then integrate each one separately by adding 1 to the exponent and divide by the new exponent. So it's 2 over 3x cubed minus 8 over 2x squared plus 10x minus x cubed over 6, 1 over 6 x cubed as you like, plus 2 over 2x squared plus x, and this all from 1 to 3. You should substitute 3 first in, or plug in 3 for each x we have in the question, and then blah blah blah, and then you know طبعا guys you have to substitute 1 and then use your calculator, so you can pause the video and do it. Okay, let's take here question 2. I will paste it here. What's the difference between question 1 and question 2? Question 2, as you see here, right and left, the second rule to find the area between two curves. Yes, the area equal the integral from c to d, right function minus left function dy. So my limits of integration c and d should be here on the y-axis. So from negative 2 to, sorry, from negative 3 to negative 2. Yes, and the right function, it's clear that it's a parabola opens to the right, and it should be positive. So 2y squared plus 12y plus 19 will be the right curve, and the left curve negative y squared over 2 minus 4y minus 10. So we can write here right and here left. Two y squared plus 12y plus 19 minus negative will be positive y squared over 2 plus 4y plus 10 dy, and then integrate easily and by adding 1 the regular factor of the, or basic factor of the integration. So also guys, I will leave this one for you to try. Yani 2 over 3y cubed plus 12 over 2y squared plus 19y, and so on. Y cubed over 6 and then plus 4y squared over 2 and then plus 10y, and then substitute from negative 3 to, sorry, yes, and then substitute from negative 3 to negative 2 and so on. Yeah, we still have one more topic to revise, so let us start here. Last topic we have to revise, which is volumes of revolutions by using disks and washers. Yes, so I promise you guys that you have a graph, and if you don't have a graph, so it will be easy for you to graph using this Desmos graphing calculator in Google. So example 1, determine the volume of solid obtained by rotating the region bounded by y equal x squared minus 4x plus 5 and x equal 1 and x equal 4 and the x-axis, and the revolution is about the x-axis. So the graph is already given, so as you see guys, no gaps here between the x-axis or the axis of revolution and the area enclosed between the two curves, so it's a disk. And you know this disk is a cross section, and it has a shape of what? Circular cylinder. It has a volume of pi r squared, and the r here is the function itself, f of x, Yeah, and the volume of the circular cylinder is pi r squared. Yeah, so it's pi f of x squared. So it's pi outside the integral from 1 to 4. I already circled here this function x squared minus 4x plus 5. And you can expand the function itself. After expanding, you can integrate each part separately because it's a basic fact of integration. Adding 1 substitute by 1 and 4. Next example, determine the volume of the solid obtained by the rotating the portion of region by y equal cube root of x and y equal x over 4 that lie on the first quadrant about the y-axis. هنا washer. Why washer? We explained this before in the revision sessions and also in our original session for volume. We said ان في gap, so أكيد هيكون washer. We said ان after revolving about the y-axis هيطلع لي solid at the right. Yes, so how to identify here the volume of the cross section? The cross section here is washer. It has two radii, the outer and the inner radius. The outer radius, which is the big R, and the inner radius, which is the small r. And how to find the big R? The farthest curve, which is the blue one now, has an equation y equal x over 4. This is the big R of the outer radius, and the small radius is the nearest curve to the axis of revolution y. Okay, so it's easy right now. 4y all squared minus y cubed all squared dy. Everything should be in terms of y because the revolution is about the y-axis. Okay, squaring the, yes, here is the small, the big R is 4y, and the small r is what? Y cube. Okay, we can square the 4y. It will be 16y squared minus y to the power of 6. You should solve first the equations up here with respect to y. So we can change it x equal by cube each side in the first equation and by multiplying each side by 4 in the second equation. Yes, squaring 4y will be 16y squared minus y to the power of 6, and integrate each one separately. 16 over 3y cubed minus 1 over 7y to the power of 7 from 0 to 2. طبعا you can find 0 to 2 من الجراف من فوق، من first graph from 0 to 2 على الواي axis. وطبعا easy طبعا to find أو complete your question. So انت معاك ال PPT موجود على الواتساب for this lesson and for all lessons, and you can check your view class. You will find all. Yes, I would like you to revise all these questions in volume especially and the areas. I hope you understood everything, and I hope you enjoy the revision. Study well, guys, for your final exam, and I hope this help you in your preparation in the final exam. Thank you and good luck, guys, and goodbye. Assalamu alaikum wa rahmatullah. Bye.